Good afternoon, class. Today we're looking at solving quadratic equations. We're going to see three methods in this assignment. There's a fourth method, but I like to wait until we get to circles to look at that fourth method. So we'll only be seeing three methods today. One of the methods, solving by factoring, isn't new. That's what we were doing at the end of class the last time. So let's see. Y'all remember solving by factoring? Well, there it is.
We said a quadratic equation has to have an x squared in it, and it has to be in that standard form, ax squared plus bx plus c equals 0. And if it's in that standard form, to solve it, you just factor and set each factor to 0 and isolate the x. And of course, there were no x's in any of the problems. Here was an example, problem 10.
Do y'all remember doing this at the end of class the last time?
Like on number 11, we had to move that 14 over, because in order to solve a quadratic equation, you've got to have it equal to 0 if you're going to use factoring. I'm just sort of rehashing what we were doing at the end of class the last time, because we're going to pick up right there. And so today there's several methods for solving a quadratic equation. We're going to discuss methods for solving, or two methods for solving a quadratic. Now, quadratic means there's an x squared in it.
And that's the biggest exponent in it. There's not an x cubed.
An equation means there's an equal sign in it. Okay? The methods that we'll see, well, we've already done one with, or some with factoring in the last assignment, but we'll do another one of those just to jog your memory. Then we'll see something called the square root method. And completing the square, we're not actually going to do today. That's a third method. I don't normally write that down.
No, but we just mentioned that. We'll see completing the square when we get to circles. It works better with circles. And so the third method we'll see today is the quadratic formula.
And if you recall correctly, it's not always possible to factor something. And remember, there were those that were prime. So sometimes if you have a quadratic equation, it might not be factorable. When we discuss the square root method, you'll see that that only works certain types of problems. The quadratic formula will solve every quadratic equation there is out there, okay?
If the solution's a real number or if it's imaginary
number,
the quadratic formula will give you the solution. The quadratic formula always works. The other two, maybe not. And let's see. How about, what do you want to do?
Let's do problem number 2. Problems 1 and 2 are factoring. Just to sort of, you might be thinking, wait, we were doing this the last time, why are we doing it again? Yeah, we did do this the last time. So this is problem number 2. It says, solve by factoring. Okay, 2x squared plus 15x plus 13 equals 0. Well, to solve an equation by factoring, it has to be in that standard form, ax squared plus bx plus c equals 0. And it's in that form. Let me see. So we'll just go ahead and jump straight to factoring it. Let's see. Numbers that multiply together to give you 2, there's not a lot of them. Well, theoretically, there's infinitely many if you look at decimals and fractions and stuff.
But you mean positive real numbers?
No, I mean positive integers.
What am I saying?
I know. Oh, wow, Tim, you need to Go back and study your number systems again. And for 13, well, just 1 and 13. So there's not a lot of possibilities here.
Oh, I like those signs.
I
we
know.
something about the signs inside those parentheses. What do we know?
Do you remember how we look at the second sign?
Okay.
The second sign is plus. We have
Two of the
first. And remember, I made a little table the last time. That's the neat thing about posting those videos on YouTube. If you're like, oh, well, wait, I wasn't here the last time, that's no excuse, okay? And even if you don't look at the January 25th video, the ones from last September that are included in the assignment, we're basically doing the same thing. Okay, so not a lot of choices. So x times 2x, is that how y'all would do it? Or 2x times x, it doesn't matter. But how should I arrange the 1 and 13? Keeping in mind, I want to get 15. So let me see. These are my thoughts here. I need to get a positive 15x. Okay. Put the 1 right here. Is that what I'm hearing? Because I think that's right. So I'll put the 1 here with the x and the 13 with the 2. If I FOILed out outer and inner, that's what these marks are. The outer is a positive 13x. The inner is a positive 2x. Yeah, I factored it correctly. It gives me a positive 15x.
Are we through? No.
No. Do you remember the discussion about the instructions? If it says just factor and that's it, then, you're finished. You have 2 sets of parentheses. But this says solve by factoring. If it says solve, you better have 2 numbers over there to type in your box, not parentheses. So set each one of these factors equal to 0. So set the x plus 1 equal to 0. And the 2x plus 13, set that equal to 0. And then isolate the x. How would I go about isolating the x? Let's see, on this one here, what would I need to do to get the x by itself? Yeah, subtract 1 from both sides. And we would have x equals negative 1. Or, as we go do this more and more, I'll just put the little arrow there to mean move the 1 over.
Transpose the term. That changes the sign.
Like right here, how would I get the x by itself? I would. Okay, subtract the 13. So we have 2x equals negative 13. The formal rule is do the opposite operation to both sides, beginning with addition and subtraction. The opposite of adding 13 would be subtracting 13. What's the opposite of multiplying by 2? Divide by 2. So we get a negative 13 over 2 as our answer. I'm just going to write it all in one color right there. Negative 13 over 2 and negative 1. Those are our 2 answers.
Y'all remember doing that the last time? Okay, so negative 1, comma, negative 13 over 2.
And you were just hitting the little...
Oh, and I just used the slash. When I was typing in that 13 over 2, you'll notice I didn't use the little fraction hot button. I only do that if the fraction I'm entering is a number over a number. If it's a messy fraction, I always use that fraction hot button. By messy fraction, I mean maybe it has a denominator of x plus 2 or something. So if it's just a pure numeric fraction, number over number, you can put the numerator, slash, and the denominator. Okay. Any questions there? Y'all remember that? Okay, method number 2. Factoring we saw the last time. Okay.
hopefully your
Okay.
ankle will be better and we can...
Resume this. I tell you.
So now he's discussing the square root method. This is new material. By new material, I mean we didn't do it the last time, but it's not new to the world of math. Okay? It's been around quite a few hundred years.
The square root method. The square root method says that if you have some quantity squared, I'll say if x squared is equal to a number n, that's an n for number, then the thing being squared has to equal the positive or negative square root of that number. Oops. I know you don't like it, but I make that little hook there.
I'm getting used to it.
And if you think about it, if you just think about it a while and you look at an example, I think you can figure it out for yourself. What numbers can we square to give ourselves 25? There are two numbers that you can square to give yourself 25. What are they? I couldn't hear you. 5 and negative 5. Positive 5 and negative 5.
Okay? So the solution to x squared equals 25 would be x equals
plus or minus, take the square root of 25. So that would be what? Positive or negative 5.
Remember,
Positive 5 times positive 5 gives us a positive 25. Negative 5 times negative 5 will give us a positive 25.
It can't all be that easy, Tim. But a word of warning. I mean, if you wanted to think of it as write it with just 5.
They didn't. My lab didn't used to have that plus minus key. They added it in at around 2019, and it was just so exciting when we saw that, because before that, here's the little blue box. Here's the blue box on my lab, and you'd have to type your answer. You'd have to type 5, comma, negative 5. Well, it's negative 5, comma, positive 5.
And that's what that plus minus is representing. It's two numbers, positive 5 and negative 5.
You can only use this method if the equation is in the form variable squared equals a number, or I should say a quantity squared equals a number. And the quantity may be something messy. You'll see that in one of the examples, but for the time being, let's start off with one that's pretty painless.
4.
Okay. 2x squared equals 26. This is number 4. Let me write the problem down. And you'll notice the instructions don't say use the square root method. Okay? It just says solve it. You recognize, hey, I have something, I could get this in the form for the square root method so that I have a quantity squared equals a number. If I'm going to use the square root method, is the 2 being squared? What's the base of that exponent 2?
Just the x.
Just the x. So we can get that x squared by itself, divide by 2. To give us x squared is equal to 13. And now this is in the form that we wanted. Quantity squared equals a number. The thing being squared on the left, well, that's an x. So we drop the square. When you drop the square, what do you pick up on the right? Positive or negative square root of 13. Hey, can we simplify the square root of 13? No, it's a prime number, so we're just stuck with positive or negative square root of 13.
That's what I'll type in.
Okay.
And right here, when you were showing this step, if anyone was wondering, well, why is he doing that, showing that, rather than just going straight to 5? Well,
I'm trying to show the logic, what I'm doing here, when it's something that's not quite so obvious.
So plus minus square root of 13.
Click in the blue
You'll
box.
notice in the instructions here, they never changed it once they put the plus minus symbol. It still says use a comma to separate your answers as needed. You don't need to because they have the plus minus, then the square root 13. Okay. Any questions on problem number 4?
Okay,
Let's see about number 5.
Okay, I like that. Let me write it down. This isn't immediately in the form we want. Something squared equals a number. But I look there and I notice, well, there is something being squared. Can we get everything else on the other side so that it's just in the form something squared equals a number? And I think we can. 4x
squared is an x squared.
Mm-hmm. 4x squared plus 20 equals 0. Okay.
What are we going to do?
Okay, first of all, okay. So we're trying to get what's the base of that square? What's being squared here? Just the x. And if you're thinking, oh, the 4 is also, there's a little dotted line test. You start at that little 2 and you start drawing the little dotted line. The first thing you hit is that x. If I wanted 4 to be squared also, and we'll see that in a moment, you'd have to have the base enclosed in parentheses. If you start there at that 2 and draw a little dotted line, the only thing you're hitting is that x. The x is the only thing being squared. So y'all said, first of all, okay, minus the 20, so that's going to give us 4x squared equals a negative 20.
Oh, wow.
And then divide by 4. We need just the thing being squared by itself, so I agree. Let's divide by 4. And that's going to give us x squared equals negative 5. We now have the equation in the form that we wanted. We have a quantity squared equals a number. Now, you say, well, that number's negative. We know how to take the square root of negative numbers. You drop the square on the left, and you pick up the plus or minus square root
and hey,
on the right.
The negative in there.
That we can't. So what are we going to do? What's going to take the place of that negative? We're going to have to write it as I, so we'll have a positive or negative, and an I in front of the square root. Remember, if you have a negative number under the square root, you would use it as if it were a positive number, but you stick an I, a factor of I on. And the square root of 5, 5 is a prime number. You can't simplify the square root of 5. Any questions there?
Especially about this I. Why is there an I here and not an I on number?
Why didn't we have
4?
an I here? Okay.
No negative in front of that 13. If that had been a negative 13, then we'd have an I here.
Okay.
So let me type this one in. Plus minus I square root of 5. So click there. Plus minus. I'll just use the I on the keyboard. Square root of 5. Any questions on that?
Okay. This is number 6. This is one of the old-fashioned problems. The fact that it's a multiple choice problem. Okay.
Now this one certainly looks different from the other ones, does it?
Here they're even saying use the square root property, although it doesn't look like the ones we've been doing.
But notice how my brother kept saying something squared, not just x squared.
It may not always be a variable by itself that's being squared. You could have something else paired with that variable. Remember the little base, that little base rule I said. Start at that 2 and draw a little dotted line. You hit a parenthesis. The entire parenthesis is the thing that's being squared.
Something squared
equals a number. So we drop the square on the left. We pick up a plus minus square root on the right. Am I going to have an I in my final answer? No, because the number under the square root, yes, it's a positive number, so we're not going to have an I in the final answer.
I think that the purple shows up better than the green. That's why I'm giving you a purple.
Okay.
But we're not finished. If we're solving an equation, it's got to ultimately be x equals.
Well, let's just work. Let's not let that plus minus upset us. Let's just pretend it was 3x minus 5 equals something. What would you do first to get x by itself? What would you do? Add 5. So we're going to have 3x equals. I'm going to put that 5. I'll move it over by adding 5. That'll become a positive 5 plus minus the square root of 33. And I should have asked something. I did this automatically as soon as I stuck that radical over the 33. Can we simplify the square root of 33? No, we can't. It's 3 times 11. There are no perfect squares that divide evenly into 33. So I remember the time we were at a conference. No, it was just a mini workshop, and we were there. The sole purpose, Pearson brought us in and paid for our hotel and food, and all we had to do was, when they were presenting it to the teacher, we had to say, oh yeah, we use it and we like it. Okay? It was a hostile environment from the very beginning. It was a very...
Well, that's enough flashbacking, Tim. Just go on with the problem.
Did you pause it as I reminisced? Yes, okay. Okay, so we're back to the problem now.
Okay, finally. We talked enough until y'all figured out what to do.
They already knew. They were like, shut up and go fast to get up so we get through fast today. This isn't that short a section assignment, but it's going pretty good. And there are 2 different ways of looking at reducing a fraction of this form. Now, if there were an I in the answer, we saw this in the second homework assignment. If we had an I up here on top, we would have to split up each of the fractions and reduce individually. If there's no I, look at the number outside the radicals. I don't see a coefficient on the square root. So what do you think the coefficient is? If you have a variable, there's no coefficient, you assume a 1, 5, and 3. Is there a number other than 1 that divides evenly into 1, 5, and 3? No. So here's your final answer. Although I'm pretty confident that my lab will accept it if you write it as 5
but
over
it's
3.
Choice.
Oh, you're right.
Wait, here.
If you were typing it in, I think my lab would accept this also.
Yeah, I think it'll take...
But I'm betting this, if it's multiple choice, I'm betting...
It's going to be like this. Mm-hmm. Is that the first one?
I think it is.
Mm-hmm. Yeah. 5 plus or minus. This is one of those rare multiple choice, paying homage to the day when everything on my math lab was multiple choice. Mm-hmm.
I remember as the problems got messier.
Oh, look, it's not multiple choice. You got to type it in. Oh, okay.
Oh, wow. Okay. Here's another one that happens to be multiple choice.
And it's another one of the quantity squared equals a number.
So, z plus 3 quantity squared is equal to negative 11.
Y'all see why I say we can use the square root method here? We have something squared and a number by itself. I want to mention something. If this were a negative 11x, we couldn't use the square root
Or
method.
Z either.
Well, I mean z. If it were negative 11z, you couldn't use the square root method. It has to be in the form quantity squared equals a number. Something squared equals a number. That's the form you're looking at.
Preferably it's just x squared, but if it's parentheses squared, it's not really hard.
So we drop the square on the left to just have a z plus 3. What do we pick up on the right? A plus or minus square root of negative 11. What are we going to have in our final answer? An I, because of that negative. Can we reduce the square root of 11? Nope, can't reduce it. So we just have z plus 3 equals plus or minus. We put the I in front of the radical so it's clear that the I is not underneath the radical. And what do we do with 11? Leave it under that radical.
And you're saying that as if you're finished, but
I thought I was, but I'm not through. What do I have to do now to get z by itself? Okay, subtract 3 from both sides. That'll give us z equals negative 3 plus or minus I square roots of 11.
I think someone went to lunch when they were programming this way back in the day.
No, I just used 3.
And they forgot to finish it and put D on here. But it's this one, right? Okay. That's the square root method. Let them look back over it, Tim.
No, I can't. You gotta switch.
Well,
There's the square root method. You get something, it has to be in the form something squared equals a number, and then you drop the square on the left, you pick up a plus minus square root on the right. And here's something, when you're factoring, you don't expect to get imaginary numbers. Think about how you're factoring. As you go through factoring, you have x's and x's in the parentheses. So the thing
also will never have square roots.
yeah, you don't have square root
fraction.
symbols. You won't have something like, here, this thing right here. You won't have that as
When you're doing factoring, you're just going to have the integers or fractions as answers.
and if you think about it, it makes sense, because think about how when you're factoring, you're not picking up square roots along the way. You go through isolating the variables, you're getting rational numbers. Now, the square root method, you can pick up those imaginary numbers.
And square roots.
And square roots, and these 6 and 7 were complex numbers. Real number, well no, number 7 was a complex number. Real number, plus or minus an imaginary number. Okay.
No.
Third method, the quadratic formula.
Go ahead and write it out.
I'm going to. Quadratic formula. Solutions of a quadratic equation written in standard form ax squared plus bx plus c equals 0. Notice, to use the quadratic formula, the equation has to be written the same way that it is when you're factoring. It's got to be in descending order, starting with the x squared, and then if there's an x, a constant, and it has to equal 0. Solutions of ax squared plus bx plus c equals 0 are given by
the formula x equals, it's a fraction, it's the opposite of b, that's a negative b, plus or minus the square root of b squared minus 4ac. All of that is on the top. And on the bottom, we just have 2 times a. Realize a is the coefficient of x squared. B is the coefficient of the unsquared variable. C in the formula is the constant term. One thing that, it's even true when we're factoring, I don't know if we mentioned it or not, but I like my a value to be positive. I like that a value to be positive, and if it's negative, the leading coefficient is negative, I'll either multiply through by -1 to change all the signs, or I'll move all the terms over to the other side. I could have the 0 on the left side, but I don't want a denominator, because 2 times a, if a were negative, then your denominator is negative. I don't have any trouble working with fractions. I have negative denominators, but unfortunately students have a tendency to do all sorts of weird things. Avoid denominators that are negative by always making sure that a is positive. And let's see, which one are we going to start?
Number 8.
Hopefully after an example that'll make sense.
Okay.
I think it will. And the rest of the assignment is square. I mean, I think this is what we're doing. The rest of the assignment is the quadratic formula. So you have plenty of problems to practice with. Oh, and they're even telling you to use the quadratic formula. Y squared minus 8y is equal to -13.
How do I make this?
I have to say, oh, that's too
Maybe
big.
it's too big, but
Yeah. Okay.
Okay. Have you written it down?
Yes, the instructions say use the quadratic formula, but even if you thought it was factorable, you'd still have to do the same first step. If you're factoring or using the quadratic formula, the equation needs to be set equal to 0. The coefficient in front of the square needs to be positive. So what do you think I'm going to do? I'll bring that 13 over by adding 13, and that -13 is going to become a positive 13. And now, if it were factorable and you solved it by factoring, I wouldn't know. You'd still get the correct answer, okay? But this thing isn't factorable.
You could try to factor it all you want. Second sign is plus, so 2 of the first. 1 times 13, there's no way you'll get an 8 out of that.
So let's identify A, B, and C. A is the first number, the leading coefficient, the number in front of the squared variable. I don't see 1, so we assume it is. B, okay. The number in front of the unsquared variable, use that sign, so that's a -8, I agree. And C, so I'm going to rewrite the quadratic formula,
Every time you use it, rewrite it.
because this is something you're going to want to have memorized.
Wait.
Okay. This says -b. That says the opposite of b. The opposite of -8 is, okay, so it's really just saying change the sign on b. The -8 became a +8. B squared. Negative 8 times negative 8. What's that going to give us? Negative times negative is going to be a positive and 64.
This is one of those times showing every single step is not necessarily helpful. The b squared you can usually do in your head or punched into a calculator real quickly. Negative 8 times negative 8, just go ahead and do that and write out 64.
And then we have a minus 4 times A times C. A is 1 and C is 13. What about 2 times A? That's something you can do in your head. 2 times A. 2 times 1 gives me a 2.
Not a calculator, is it opening?
What is that?
Oh, wait.
Okay. Working under the radical. We remember the order of operations. We can do this multiplication. A minus 4 times 1 is a negative 4 minus 13. Times 13. Here's my thought process. I have a 64. That's a minus 52. What's 64 minus 52?
And to demonstrate your thought process, Tim, I'm punching it into a calculator.
Okay, I'm getting a 12 under the radical.
4 times 1 times 13. 4 times 1 is 4 times 13, 52.
The thing under the radical, b squared minus 4ac, is called the discriminant. The term isn't important, but what's important is that the value of the discriminant determines whether you're going to have an I in your answer. Am I going to have an I in my final answer? No. If the thing under the radical turns out to be negative, you're going to have to reduce it using an I. If the number under the square root turns out to be a perfect square, then you're not even going to have a square root appearing in your final answer. But here, is 12 a perfect square? You're going to have to reduce the square root of 12. What's the largest perfect square that divides evenly into 12? Okay, here's how you're thinking of it, okay? You're thinking of that 12. This red is my thought process. That's 4 times 3. So, the square root of 4, that's 2, okay. What are we going to do with the 3? Leave it under that square root. And we still have a 2. And I'm going to make what's a classic new teacher mistake. About doing what I'm about to do, I'm going to work it 2 different ways. I'm going to reduce this 2 different ways. There are 2 ways you can get an acceptable answer. One way is just to do what you did with the i's. If there's an I on top, we know split up. So it's 8 over 2 plus or minus 2 square roots of 3 over 2. And then you can cancel 8 divided by 2. What does that give us? 4, okay. Plus or minus. What's about to cancel there very nicely? The 2. So you just have a square root of 3.
And that's the separate method.
In this case, you're going to get the same answer whether you do the separate method or that factor and cancel method. Now, how did you come up with 4 and the square root of 6? Are you working my problem, or are you working the problem that your homework problem?
I'm looking at yours.
Oh.
Oh, well, 24. I mean, no, 12. You would use 4 and 6 if you had a 24 under there.
I did an 8 plus minus square root of 12 over 2, and then I reduced the 2 into the 8, 4.
Okay.
And it was plus minus.
Oh, and you
then
cancel the 2 with the 12.
12.
No.
You can't cancel the number in the bottom
That's right,
with the number.
with the root.
Uh-huh. But once it's written like this,
Once you have it like this, there is another way of canceling. Look at the 3 numbers outside of the square root. The coefficient, this constant, and that denominator here. What's the biggest number that divides evenly into 2 and 8? The 2.
if you divide
So,
the 8 by 2, you get a 4.
I'm going to take out a 2. 8 divided by 2 gives me a 4, plus or minus. 2 square roots of 3 divided by 2 gives me 1 square root of 3. And I still have this 2 down here. You can't cancel over addition or subtraction. You can only cancel if it's multiplication. That's what we have here, 2 times all that stuff. So we can cancel the 2's. And either way, we still get 4 plus or minus the square root of 3. But I'll warn you, you don't always get the answers that look the same. If you split up, your answer may look different if you factor and cancel. And if you're viewing an example, they may be splitting up to reduce, and you may be factoring and canceling. And so your answers could look different, but they're still equivalent answers, and my lab would accept it. Any questions there?
So should we always split it up? Would you say?
I have, the rule that I use is if there's an I always split it up, and if there's no I factor and cancel. But that seems sort of stupid because splitting up always works. And so last semester I started saying, you know what, the safe thing to do to make sure that your answer is in the way that my lab will count it, split up. Okay? Even if there's no I, you split up and reduce. Any questions there? Okay, let's try typing in the answer. Watch, after all of this, they say it's wrong.
Oh, let me see. There. So what was it? 4
Plus or minus,
plus or minus
the square root of 3.
square root of 3. Any questions on that?
Let's do another one.
Let's do 9. Jump to 12.
Let me write the problem down. Two x squared minus 11. Okay, 2x. The instructions say to use the quadratic formula, but if they didn't and this thing were factorable and you factored it, you'd still get the same answer. But I've learned one thing. If my lab says use the quadratic formula, they're trying to subtly tell you it's not going to be factorable. Okay? There's really only one correct first step here. What is it? I couldn't hear you.
Yeah,
okay,
right.
get the 1 over.
Move
You're moving that 1 over.
How about these red? Add some color to it.
Oh, goodness. So that gives us 2x squared minus 11x
Plus or minus?
minus
Minus
1 equals 0. Let's identify our A, B, and C values. A is equal to 2. B is equal to negative 11, I agree. And C, negative 1. And we're going to have to remember to get a new
formula.
notebook for this class.
Oh.
Okay, I'm rewriting the quadratic formula. The opposite of B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's start making the substitutions. The opposite of b, the opposite of negative 11 is positive 11, plus minus the square root of negative 11 quantity squared. Negative 11 times negative 11. Negative times negative is positive. 11 times 11 is a positive 121. And I always get emails from people telling me that their calculator's messing up because it's saying that negative 11 is a negative 11 squared is a negative 121. And if you look at this calculator, negative 11 squared, what's that going to give you?
Why is it giving us the wrong answer?
Remember my little rule? That negative that's in front there
is it being squared?
The only thing being squared, if you draw a little dotted line, all you hit is that 11, not the negative. If you want to square a negative number and you're using a calculator, you need to make sure you enclose that number in parentheses.
If I'm just squaring a negative number, what I normally do is negative times negative positive, and I would just stick 11 into the calculator. But if you want to actually punch in negative 11 squared, you've got to have those parentheses.
Just make a note, b squared is always a positive number. And then we still have minus 4 times a times c. 2 is, what do you say, 2 and negative 1, okay. What about the denominator? We can do that in our head. 2 times a, 2 times 2, I agree with 4. Let's work underneath that square root. So negative 4 times 2 is a negative 8 times a negative 1. That becomes a positive 8. So here's what I'm thinking in my head. I have 121 plus 8. I know that's 129. Question, I couldn't hear you. Oh.
4 times 2 times 1 is 8. Negative times negative is positive. So 121 plus 8. So see how we're getting a 129?
Oh, and you punch it into the calculator also. Am I going to have an I in my final answer? No. Is 129 a perfect square?
I don't think so. It's a decimal number, right? Wonder if some of you have one of those wonderful Casio calculators. Punch it in and see.
I have 2 in my briefcase, but I'm not pulling it out.
Okay.
I noticed it's divisible by 3. 129 will divide by 3. You're saying, well, 3 isn't a perfect square. Maybe the number we get will be a perfect square. Maybe it'll give us an idea. Hey, that's a prime number, 43. 3 times 43.
Well, any perfect squares like 4, 9, 16. How far do I need to go before I decide? Nothing's going to divide evenly.
It goes back to what I was, if you're working along, even though the numbers are being randomly generated, there's an algorithm to stop it from getting out of hand. If you run onto a square root and you think, oh, I have no idea what divides evenly in there, it's a good chance nothing's going to divide in evenly. That square root of 129 cannot be reduced. So if it can't be reduced, is there a number here that we can factor and cancel?
There it is.
You can leave
Oh.
it like this or separate it.
And I found that my lab, now remember if there's an I and you leave it like this, they're going to count it wrong on the test. And what I'm worried about is how you type in your answers for the test, because if you type it in like this and they want it split up in the homework, well, you just correct it and type it in the way they want it. But you don't get that option on the test. So that's why maybe the best thing to make sure you're always typing in the answer the way MyLab wants it. What did you say do? Split up.
Awesome.
11 over 4 plus or minus the square root of 129 over 4.
But once you've taken a test, you get to look back at it and stuff. If there's ever a time when, oh, you didn't split it up, even with an imaginary number, if you left it in a correct form, let us know and we'll look at it, okay? But the test being randomly generated and the problems in a random order, it's hard for us to look through everyone's test and every single problem, okay?
So the homework, it doesn't do it, but the test, it does.
Oh no, I mean, if it does it if it takes this in the homework, it'll take it on the test. But there are some times in the homework, it's got to be written like this. If there's an I in it, if there's an I, you've got to separate.
Okay.
If there isn't an I, you don't have to separate. You can if you want, but you don't have to.
Which form do you want us to type into MyLab? We haven't even typed in the answer, have we? A or B? You tell me what you want to type in. The first box or the second box?
The first box is the easier way to type it in, but I think I'll type it in like this, or not.
Well, I was going to let them choose. I was giving them a choice.
Find one that has the I.
What did you say?
Oh, we'll have some with an I before it's over.
See if you'll accept it split. Okay, we're going to do the second one. I know it's going to. We went through this last semester. But before you type the plus minus, what do you have to do? Get out of that denominator, tab or hit a right arrow.
And I'm going to use this little button for the fraction because it's sort of messy. The square root of 129 over 4.
Unless they change the programming over winter break.
Always take it if it's split up.
And the fractions are reduced. They wouldn't accept it if it were 22 over 8. The fractions have to be, if there's a common factor, you have to cancel them.
Let's see.
Any other questions there?
Let me see. I want to really... While we're discussing that, move straight to 14.
Okay.
Negative 5x squared equals negative 13x plus 14.
So my question about that is, does everything always have to have the 0 on the right side?
No, as a matter of fact, I like the way you're thinking. You know you want that number in front of x squared to be positive. And so the easiest way to get a 0 on one side and a positive leading coefficient, move the negative 5x squared over to the right, and that's going to become a positive 5x squared minus 13x plus 14. Remember, we said that the number in front of the squared variable needs to be positive. We said that we need a 0 on one side. But equality is reflexive. This line here is still read as 5x squared minus 13x plus 14 equals 0.
I remember years and years ago, a teacher saying she just doesn't get it. She has students in her class They just cannot stand to have the 0 on the left-hand side. And I said, well, if they do that, you tell them just to mark it out and do this. Same thing. Okay? So, I don't know if she ever did that, but that's what I told her to do. Okay?
She probably left there shaking her head thinking,
That
that idiot twin boy.
Yeah.
Oh.
So now write down the quadratic formula. No, write down your
Identify A,
value.
B, and C first. Y'all call out A, B, and C. A equals 5, I agree.
Always want A to be positive.
B equals negative 13. And C equals 14, I agree. And we recall the quadratic formula. I'm just such a big writer. That's one of those things that I'm going to have to get a notebook that doesn't have college rule lines on it.
Yeah, I keep meaning to go to the store and buy some. And
I know. I keep forgetting too, Tony, so... Okay.
Huh? Oh, no. I was going to say, let me move my calculator over here. And I'm going to do B squared on my calculator when you're ready, Paul.
Okay. Negative B. The opposite of negative 13 is 13. B squared, negative times negative is, and 13 times 13 is 169.
Notice how with the calculator, I didn't punch in the negative. I know negative times negative positive, so don't worry with it. If I'd done this,
you would incorrectly
give me the wrong answer. And it's not the calculator's fault, it's my fault for not putting the 13 in.
Negative 13.
I mean the negative 13 in parentheses. Okay.
Then minus 4 times A times C. A is 5. And C is what, 14?
And you know, this is getting sort of messy, so let's just punch it into the calculator. I'm punching in what's under the square root. 169.
Minus 280.
Minus 4, parentheses 5, parentheses 14. I was going to illustrate this. Okay, so we have 169 minus 280, so a negative 111.
We're not through with the denominator, though. What's the denominator going to be?
Oh, I forgot about that. What's the denominator?
10, I agree. 2 times 5 gives me a 10. Okay. Any questions with that discriminant, the thing under the radical? 169 minus 280 gave us a negative 111. I can't hear you.
Bring the I out.
Oh, bring the I out. You're right. Oh, wait. Negative 111 all over 10. And so that negative 111, we're going to bring out the I. Y'all are really on the ball. So we're going to have a 13 plus or minus. There, bring out the I. What about 111? Is that a perfect square? No. 121 is a perfect square. 111, is there a perfect square that divides evenly into it?
It was my fault. 4, 9, 16. Stop me if the perfect square divides evenly into. Well, if you think I've done enough, then I can just stop.
Here's something I noticed. 111, 1 plus 1 plus 1 is 3. That's divisible by 3. Take 111 and divide it by 3. I bet you we're going to get a prime number. 37. There are no perfect squares that divide evenly into 37, so the square root of 111 cannot be reduced. Once again, If it's an odd looking number that you rarely see under square roots, it seems like the program is designed not to make it too messy. The square root of 111, we leave it as the square root of 111. There's an I on top. That we're going to have to separate them. 13 over 10 plus or minus I square roots of 111 all over 10.
Oh, that'll be a little messy to type in.
13 over 10, is there a common factor to cancel? No. There's no number here to cancel with the 10, so there's no reduction further.
Give them a couple of seconds to catch up before I punch it in. Maybe I should punch it in first to make sure we got the
Your
right
faith
answer.
in us is overwhelming,
I know.
Tony.
Yeah. Okay.
January made, what was it? 36 years that we've been doing this in front of college classes?
Mm-hmm.
So surely
Oh,
we
wait,
got-
I think I've covered up my plus minus key. There it is. Down here. Oops. 13 over 10. Plus minus. Oh, messy looking fractions. So I'll use this button. Ooh, I'll hit this I instead of using the keyboard for no reason. Square root 111 over 10. You'll see how I'm typing this in? It can be a little messy.
Any questions? Go back.
I want to do number 12, I think.
Mm-hmm.
Yeah, number 12.
Oh,
Oh, what are you going to go back?
okay. I was just reading what the answer said.
Express,
The instructions said.
express
any-
complex numbers in terms of I. Huh?
Okay, put this back here.
Oh.
Any questions here? I'll cover over that. You need the equation. If you're using the quadratic formula, you need a positive leading coefficient. You need one side set equal to 0. Most of the times, you'll get the 0 on the right. But sometimes, if you have a negative leading coefficient on the left, it's easier to transpose terms and get that 0 over on the left.
And hopefully that doesn't bother you. It's not like you're really doing anything with that 0, is it? This is the part you're using the ABC on.
Okay.
Any questions? Let's go back and do number 12.
Okay. Solve the equation using the quadratic formula. Okay. Solve the equation. It says use the quadratic formula. I could have heard. Okay, so we already have a leading coefficient here. Well, what's the leading coefficient? I don't see anything. It's a 1, it's a positive number, so we don't want to move that x squared. So I agree, let's subtract that 6x. Okay. So x squared, it becomes a minus 6x. I couldn't hear you. So you're moving now that minus 25, you're going to add 25. Remember, when I say I can't hear you, it just means I can't hear you. Loud music at a young age, a father that thought loud stereo systems were important and status symbols.
Gosh. Oh, wow. No, in case you're wondering, wait a minute, why on 14 why don't we just do the same thing here and move the x squared over? Then we'd have a negative x squared. You never, ever, ever want a to be a negative number, because do you ever want negative numbers in your final answer in the bottom of a fraction?
No.
No.
Ever have to happen?
Okay.
Will that ever have to happen?
If it does, you've
The-
messed up. If you wind up with a negative number in the bottom of that fraction, you've messed up somewhere. Okay? So write out A, B, and C.
Okay, let's see. Y'all tell me. A, positive 1, I agree. B, negative 6. C, 25, okay. Now rewrite that quadratic formula. X equals negative b plus or minus the square root of
This is better, Grant.
b squared
Maybe not.
minus 4ac all over 2a.
I know I can do the 2a in my head.
So here goes. I messed up there. Okay. That green is too pale. I'm not going to use that green. Negative b. The opposite of negative 6 is. It seems like every time, every example we're choosing today, the b value is negative. It doesn't have to be. If b were a
The
positive
next one's
6.
going to have a positive b.
Oh, okay.
I
So
think.
if b were positive, then in this step it'd become negative. It just seems like every example today,
Yeah,
the b value has been negative, and you change it to positive. B squared, negative 6 times negative 6 gives me 36, I agree. And then we have a minus 4 times A times C. I couldn't hear you.
1 and 25.
1 and 25, I agree. All over. 2 times 1, 2 times A is, 2 times A, 2 times 1 is 2. So we have 6 plus or minus. What are we going to have underneath the square root? We have a 36 minus 4 times 1 is 4 times 25. I agree. That's 36 minus 100. Here's my thought process. 36 minus 100, that gives me a negative 64. Or you can punch it into your calculator right there. And the denominator is still just a 2. The square root of negative 64. We're going to have an I because of that negative. What about the square root of 64? Is 64 a perfect square? Yes, it is. I think that's the first time we've had a perfect square under a radical. Am I right today?
Yes.
6 plus 8i all over 2.
Well, see how we got the 8i? Square root of 64 is 8.
The negative said we'd have to have an I, and the square root of 64 is 8.
And then do you have to split it up? If we
You have to split it up. Split it up.
Make the universal marks.
Oh yeah, for splitting up. I forgot about that.
How you
There.
don't know universal marks?
Universal marks that you made up yourself are by definition not universal marks, Tony. 6 over 2 plus or minus 8i over 2. 6 divided by 2 reduces very nicely to 3 plus or minus 8 divided by 2 gives me a 4i.
can I just write 7 to them?
Can I write 7i instead? No, you can't combine the thing that has the I with the thing that doesn't have the I.
Not like terms. So I'll write 3 plus or minus 4i.
Okay.
Are we ready to do the hardest one? The last. Let's do the last one. You ready?
I guess, yeah. And once we're through with this, there's one that I want to make up and do, okay?
Yeah.
So,
I'm wondering if you need to use another sheet of paper.
I think I'm going
Because you're a
to.
big one.
I was
Does
always.
it look different from the other ones? Yes? What seems odd? Okay, good. A and B are fractions, right?
1/3 x squared plus 1/15 x minus 1 is equal to 0.
Ignoring the fractions, it's in the standard form. Ax squared plus bx plus c equals 0.
We have a positive leading coefficient on one side, 0 on the other side. It is in standard form. So we can go through. A is 1/3, B is 1/15, and C is -1. And I remember in my 9th grade algebra class, Mrs. Clark, I'd gone through with the quadratic formula using the fractions. Somehow or another, I missed the part where she went through the examples of getting rid of the fractions like this. And so I went through with all the fractions, and then when she graded the homework and returned it, she'd made a note. Oh, there's an easier way rather than doing all that work with those messy fractions. Remember, you can multiply an equation by anything you want to on both sides, as long as it's not 0. You can't just multiply everything by 0, because you turn every equation in the world into 0 equals 0. But you can multiply by any other thing you want to. Here's the thing. What number could we multiply through by? There's a lot of them, actually. I'll just be looking for the smallest number. I want the smallest number that these denominators will divide evenly into. We need a number that 3 divides evenly into and 15 divides evenly into.
15.
I couldn't hear you. 15? I think that's it. What I would do is I'd take it's called the least common multiple, or if you were trying to find a denominator, it would be the greatest common, least common denominator. You take the bigger number, 15, and just start thinking. 15 times 1 is 15. Do the other denominators divide evenly into it? Does 3 divide evenly into 15? Yep, so 15, once again, they're not making it bad for us here. They're just trying to...
15 up here to show what you're about to do.
Remember, if you're trying to multiply a sum or difference by a number or a single quantity, you have to distribute. So I'm going to show the distribution. Let's go through and multiply every term by 15.
If you remember how to multiply fractions, you might see where this is going.
So you multiply?
I multiply every term by 15, even the 0, which changes nothing. But why? What can I do? Think about how you multiply fractions.
Can't you say 3 goes into 15 5 times? 5 times 1 is just 5x squared.
Maybe you should mark out the 3.
Okay. What's about to cancel out right here? And so the coefficient would be a 1x, okay. There's no denominator here, so there's nothing to cancel out. 15 times 1 is just 15.
0 times 15 is 0.
I think that looks easier for A, B, and C than the 1/3 for A and the 1/15 for B.
Now let's see, what did we do? We found the smallest number that 3 and 15 both divide evenly into, and you multiplied through by them, canceling out every denominator. Now, there are other numbers that would have done it. 30. Doesn't 3 go evenly into 30? What about right here if you put 30? Doesn't 15 go evenly into 30? 3 times 15 is 45. You could have used 45. The only thing is, if you use a bigger number to cancel them out, then these numbers are going to be bigger, and you're going to have more reduction at the end. So try to use the smallest number that the denominators both divide evenly into. That's the least common denominator.
Like 3 would cancel out the first denominator, but we can't use it because if you put a 3 here, would it completely cancel out this 15 denominator?
No, you would have what? A 5
changes
down
to
there in the
5.
denominator. A
Remember
common
Gibby's
mistake.
teacher?
She would go through with the first denominator. They'd multiply everything by the first denominator. Then they'd take
the next denominator, multiply everything through by it. Okay? And that would work. It's just more steps. But are we ready to use the quadratic formula right here?
Let's identify A, B, and C. What's A? 5, okay. B and C. So we can identify A, B, and C and rewrite the quadratic formula.
At this point, everyone has the bottom memorized. Right?
Right. Everyone has the bottom part memorized
That's the writing
at this
down.
point. Okay. Here's my plus, minus, and my square root.
Oh, look at this. Negative B.
Negative B, the opposite. Hey, we finally have a B value that's a positive number. The opposite of positive 1 is? Negative 1. I agree. B squared, 1 squared is? 1. Minus 4 times A times C. A is 5. C is negative 15. All over 2 times A, 2 times 5 is 10. Good. For a moment, I thought we were going to have an I in our final answer, but are we going to? That negative times a negative, that's going to become a positive. 20 times 15, is that 300? I'm getting a 301. So plus or minus. I have a negative 1 plus 301. Did you punch that into your calculator for them to see?
540 times that.
Okay. Oh, you did. Okay. 1 minus 4 times 5 times negative 15. So square root of 301. Is 301 a perfect square? No. Play around with your calculator. You know what I'm thinking? Do you think the square root of 301 is, can be reduced? Now, I don't think it can be reduced. Now, here's a warning. If you had used a number bigger than 15, say you used a 30 or a 45 to cancel out all those denominators, I bet that number under there would be reducible. And you'd have to go through, finding the biggest number that divides evenly in, and simplifying from there. But as it is,
There's no number there, so there's nothing we can factor and cancel. And there's no I, so my math lab will accept this as the answer. But
It would also accept it if you break it up.
negative 1 over 10 plus or minus the square root of 301 all over 10.
How do you want me to type it in?
Let them decide.
Oh,
Okay.
how should we type it in?
How do y'all want it typed in? As a single fraction or as the sum and difference of two separate fractions?
We already did the separate, so might as well try it combined.
Okay.
Oh, I'm sorry. Oh, let me get rid of this. Okay. Oh, it's so messy. Since it's a big fraction, I'm going to use this bar. Negative 1 plus minus square root of 301 all over 10. Okay, and if it separated it, it would have taken that too. Okay? Now, if
Unless
there'd been
they
an
changed
I
the
in
programming from last semester to this semester, they would take it if it's, they always accept it separated.
But if there's an I, it won't take it together, written all as one fraction.
If it's an I, you've got to split up.
And I think what we want to do right now
Okay, let me
is
just,
go
I think
back
I
to
know,
problem 2.
wait, okay. There was one I was going to do. Okay.
Oh,
Mm-hmm.
oh, but,
Is there
Here.
any way we can go through one more fraction? One?
oh, let's see. Let's say
That's
similar
what we're
question.
doing.
Oh,
We're going to be doing more fractions on Wednesday, but let me do this, and then we'll do a similar problem going back to the fraction. But there's one I want to do right now. 5x squared plus 22x plus 21 equals 0.
well, I was going to do the one we had already done by factoring, number 2.
But that wasn't that.
Oh,
I guess
that
that's
wasn't?
that was just the 2 and the 13, right?
Oh, okay, okay. Oh, so you're doing good. Okay, so
Here's one I want to solve by the quadratic formula. Notice it's already in the desired format. We have 0 on one side. We have a positive leading coefficient on the other. Let's identify A, B, and C. A is equal to, B is equal to, and C is equal to, and we rewrite the quadratic formula. I should have gone to another page. I'm going to have to write small. Hold on.
oh,
Don't do that. You're right. What am I thinking? Right here.
huh?
It up a little bit.
Oh,
Okay, that's better. Negative B. Negative 22
see, there's another one for it.
plus minus the square root of 22 squared. 22 times 22 is 484. I looked at Tony's calculator.
So what we've done here is he's chosen a problem at random, not really at random, to do. Has a bit bigger numbers.
So we have 484, 22 squared minus 4 times A times C, all over a denominator of 2 times 5 is 10, and
I'm just going to say instead of using the parentheses for multiplication, I'm just using the times button. And let's see what we get underneath here. Square root of 64.
Oh, look at that. 484 minus, that's 20 times 21. So that would be a 420, am I right? So 484 minus 420 gives me 64. I think this is the first time this thing has happened. Are we going to have an I in our answer? No. Are we going to have a square root left in our answer? No. You have negative 22 plus or minus, what's the square root of 64? 8 all over 10. If you don't have an I and you don't have a square root, that means that in your final answer, or in your answer, then that means it could have been solved by factoring. This problem is one that we did the last time. There was one that had that variable s, remember? And we said if we ruled the world, the first thing we do is we'd get rid of all variables except for x, y, and z. 5x squared plus 22x plus 21. And we got these two answers right here. Well, that doesn't look like what we have here. You can't leave it like this. You have to split it up into the two possibilities and reduce. So, if it's factorable, you can still solve it using the quadratic formula. Suppose you're trying to solve an equation by factoring and you just don't see the factorization. Maybe the numbers are big and you can't find the correct factorization. You can always use the quadratic formula. We have negative 22 plus 8 over 10, so that's the first one. Negative 22 plus 8 over 10. Negative 22 plus 8, that's a negative 14 all over 10. And we can cancel a 2 above and below there to get what? Okay, let's see.
Is that one of the answers you got the last time?
Did we get negative 7/5 as an answer the last time when we solved this thing by factoring? Yeah, there it is, negative 7/5.
How do we get this negative 3 as an answer? Well,
I think I'm going to have to write it down. Well, I'll do it.
This up just like
Oh, that does it, okay.
Negative 14.
Okay, add
Negative 22 plus
You're
8.
doing the plus 8. Negative 22 plus 8 to add a
How do you
positive
assume
and a
that as
negative.
plus sign?
Huh?
How do you,
This plus.
Right?
This plus right here is the one that he wrote right there.
but how do you assume that it's a plus, not a minus?
Well,
you
we're now
don't.
doing the
It's
minus.
both. He's about to do the minus. It's both of them. There's a plus 8 and then there's a minus 8.
That plus minus means there's one possibility with the plus, the other with the minus. Negative 22 minus 8 gives me negative 30 over 10. What's that going to reduce to? Negative 3, is that the other answer we got? We solved this equation by factoring. Is that the other answer? Let's see.
Negative 3.
There it is.
And negative 7 over 5.
Negative 3, negative 7 over 5. Here,
So even
negative
if you
3
can't
and negative
factor
7
the
over
five,
5.
Even if you can't get it factored, the quadratic formula will get it. But if there's no i's or square roots, you don't stop here.
You have to break it up into two possibilities and get two rational solutions.
And this isn't something you'll actually see us doing much in class, because if it's factorable, we're going to factor it.
Well,
We're able to factor it.
yes, but there are a few problems in the upcoming section, the square root equations, where
Just the numbers are so large that maybe it's easier to do this.
rather than trying to go through the possibilities of factoring. But if it's factorable and you're using if you're solving using the quadratic formula and you have no I and no square root left, you cannot stop there.
You can't leave it as a plus minus option. You have to split it into two possibilities.
We say plus minus, but it's negative 22 plus 8 and
then
negative 22
minus
minus 8.
8.
All over 10. Okay? Any questions how we got those numbers? Because if you did have something that you were trying to factor and the numbers were just really big, or you just don't see it, how to factor it, then the quadratic formula will do it, but you have that extra step at the end.
And next time when we're doing some square root equations, we'll get some messy, we'll go through a process to get rid of the radicals, then we're going to get some quadratic equations. Sometimes, you know, it might have a plus 142 here as a constant. And
It's
what I
easier to do this.
if I'm trying to solve a quadratic equation, they don't tell me a method, I try to factor. But if I can't get it factored within a minute or two, I go to the quadratic formula.
The quadratic formula always works.
Okay, let's shrink it down.
Okay, oops.
And let's look at another
Let's
one.
look back at number, here's a new, you wanted to do another one with fractions, so here it
I'm
is.
trying to figure out the dividing thing, like I don't understand it, I guess.
Oh wait, let's
So
review,
you do 21 over
let's review
1.
multiplying fractions.
Okay.
Like, does it always have to be,
Oh, okay.
does it always have to be the other, like the second one, the 21?
Oh, it's usually the biggest number. Usually it's just the biggest number there,
So
but
21 over 1.
let's
But
see.
this is assuming that there's no variables in the denominators. We'll see this in more detail. Solving equations, abstractions, we'll see
I
that in
think
more
right
detail.
now she's talking just about the ones that have just pure fractions, numbers as fractions.
Right.
And so if we had something like this, 12 times 5, 10, switch it over here. Just, do you remember how this cross canceling works with fractions? Now, if you had something like 12 times 5 over 6, you could say, okay, 6 goes into 12 2 times 5 is 10. Now, we're making the assumption you remember how to do this sort of multiplication where you can cross cancel. And it doesn't work just for, if it's two fractions, it doesn't have to just be an integer in a fraction. If we had 5/8 times, let's see, 12, what am I looking for? 12 over 25. 5 over 8 times 12 over 25. My goodness, my handwriting's messy. How could you do this cross-canceling? Well, you can say 5 goes into 25 5 times. What about this 8 and 12? What could I cancel in both of those? A 4, so that would leave a 3 there and 2 there. Giving me what answer? 3 over 10. So keep it in mind the way you can cancel there on that problem number 15. What was it?
Oh,
1/3 x squared plus a 1 over 21 x minus 1.
it's not changing much.
Yeah, it doesn't. This one doesn't change much.
That
Oh,
would have
like
been
right
better.
here, what would be a here's a viewing example. What would you need to multiply by to get both the 7 and the 35 to cancel? The 35. If you multiplied through by 7, it would have completely cross-cancel with that 35. But that's not the one we're doing. How do you hit view an example, Tim? You're coming right there. Okay. Huh? What would... Look at the biggest number in the denominator, and usually that's the thing that will work. It'll cancel out both of the denominators.
But if it didn't, then you just keep going through multiples of 21. 21, 42, 63. But here, if I multiplied straight through by 21, can I do that cross-canceling stuff? Even the 0 and the 1 get multiplied by 21. Yeah, let's see, doing the cross-canceling. 3 goes into 21 7 times. So we have 7x squared plus what here? The 21's just cancel. 1x is just x. Minus a 21 equals 0. And why did we multiply through by 21? Well, I just think it'll be easier, A, B, and C being 7, 1, and negative 21 versus having a fraction for A and a fraction for B and a negative 1 for C. But it'll still work. It'll just be a lot more involved if you do. So A is 2, A is 7. What's B? A 1. And C is negative 21. We'll write down the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2 times a. Okay, so what am I going to replace negative b with? It'd be negative 1. Are y'all caught up? Any questions?
It's just fractions, sorry. Everything else is
Oh, wait. Do I need to go back to what I was doing with the fractions?
No, it's okay. I'll figure it out.
Oh. But it's that cross cancel, huh?
That's always been my weakness, is fractions.
But you're getting rid of the fractions real quickly.
Yeah.
And for this problem, you're going to multiply by the biggest denominator. Next time we'll see how to get rid of them if there's variable. Instead of 3 and 21, suppose there's an x and an x squared in the bottom. Okay? So this is just a slight hint of what's ahead of us. Let's see. B squared, I can do that in my head, right? 1 times 1 minus 4 times A times C. A is 7. C is negative 21. Tim, when I'm writing this, you want to be punching that in. And what number do I have on the bottom? 2 times A. 14. Is that what I'm hearing? So now let's simplify all of this. And have this, what, oh, I can't, what is that, 589? Oh my goodness. 589. And how did I get that? I punched it into my,
It's not even visible by
calculator. Yeah.
I don't think there's a perfect square that are
I'm
divided
gonna go on
equally.
over.
And it's
Yeah.
not a perfect square. Let me confirm that.
Yeah, let's
for
make sure
y'all.
the square,
No. So I don't think it's reducible.
so we have negative 1 plus minus the square root of 589 all over 14. And if you want to separate it, or take it separated, one thing you cannot do, well, even if it could, divide 589 by 14. Okay? So, or negative 1 over 14 plus minus square root 589 over 14. So however you want to type it in.
Okay, I have one I want to do.
Oh wait, let me type that in just.
Okay.
It was one of our problems. Oh, yeah, I think I'll type it in as two separate fractions. Negative 1 over, oops,
It's on the calculator.
negative 1 over 14, right arrow, plus minus, fraction, square root of 589 over 14. Okay. Now, what was it?
I have one more that I want to do. We don't have to work it all the way through. I just want you to help me get rid of the fractions.
Okay.
Okay.
The EX, for example.
The EX is, for example, I'm going to say rewrite without fractions. But we don't have to solve the equation. I just want to rewrite this thing without fractions. Oops. Damn it. Oh, I mean, I did. I think I gave away the punchline. Okay. 1/3 x squared plus 1/2 x minus 2 is equal to 0. I need to multiply through by something that 3 divides evenly into and 2 divides evenly into. 6, the least common multiple. 2 times 3 is 6. Multiply by 6. I write it as a 6 over 1. I think you were just writing it as 6.
I should have written it as 6 over 1.
Well, I just write it as 6 there. If I'm multiplying an integer, I write it as an integer. If I'm multiplying a fraction, I write it as a fraction. And then, okay, let's see. 3 goes into 6 2 times. 2 times 1 gives me a 2x squared plus, you tell me what this middle term is going to become. Okay, 2 goes into 6 3 times. 3 times 1, I agree with 3x minus, okay, there's no fraction there, you're just multiplying. 6 times 2 is 12 equals, and here, 0 times 6 is 0.
See, which one would be easier to use the quadratic formula on? The one without the fractions. But amazingly, if you do it with the fractions, a equals 1/3, b equals 1/2, c equals 2,
Negative 2.
a negative 2, you get the correct answer
Eventually.
unless you mess up somewhere. Okay, so does that help at all with how we're getting rid of these fractions? Tim, you put an A there. We're going to do a B?
I was thinking I'd do a B.
Oh, okay. And this is the last one.
This is the last one.
Okay.
Okay, this is the last one. I'm going to say a
4/5 x squared
4/5 x squared minus
3/10 x
minus
a half
mm-hmm.
equals 0. You don't have any of this messy, but if you can figure out how to get rid of the fractions here, you've mastered it.
We need a number that 5, 10, and 2 all divide evenly into.
10?
Did I hear 10? I think 10
Will
is...
10 cross-cancel with every one of these denominators?
Let's see. If 10 is the correct one, then every denominator should cancel out. 5 goes into 10 2 times. 2 times 4, that's an 8x squared. Is 10 going to cancel out here? Yes, 10 goes into 10 one time. What are we left with? 3x minus, here, 2 goes into 10 5 times. 5 times 1 is 5. And here? Okay. Okay.
I hate to say, any questions? Does that help at all?
No, it's a
No?
I'm like,
I love it. Okay.
Oh, it's a cold.
fractions are my weakness, but like I said, I'll figure it out. But I have lots of notes to kind of rely on.
Oh,
Okay.
And you'll see us doing more of these in the other videos that are posted in there.
It's so different.
Okay.
It's like being body.
Any questions? We're stopping recording.
I'm going to stop recording.